It began as the faintest echo from the darkness. A flicker so small it seemed accidental. Just another stray glint in the ocean of starlight that stretches endlessly across the universe. Astronomers almost ignored it, brushing it aside as a routine, unremarkable comet wandering through the void. But that illusion did not last. The object, later designated 3I, Atlas, quickly shattered every expectation. It refused to behave like ice-rich bodies drifting aimlessly between the stars. Its light intensified with a brilliance that no known natural process could explain. It shimmered with an unnatural green radiance, yet none of the usual molecules linked to that color were present. And the way it reflected sunlight defied the behavior of any comet ever catalogued. Almost immediately, the world's observatories, Hubble, Webb, Gemini, TESS, and dozens more, locked onto the intruder. What they found overturned decades of cometary science. Instead of a frozen relic from another system, 3I, ATLAS looked like something foreign to physics itself. Its motion was too precise, too sharp, and its luminosity surged unpredictably, as though responding to something unseen. The first images from the Atlas survey in Chile showed a small, compact nucleus wrapped in a coma expanding far too fast for its size. Its tail didn't simply stream away from the sun, it twisted back toward it, as though shaped by forces unknown. At first, researchers suspected faulty instruments. But one by one, observatories around the world confirmed the same impossible readings. Worse still, data from exoplanet hunting telescopes revealed that the object's brightness had flared long before it ever entered the inner system, at distances far too cold for any natural comet to activate. A chilling realization slowly took hold. 3I, ATLAS wasn't just active. It was reacting. When James Webb turned its infrared eye toward the object, the mystery deepened. Instead of water vapor and simple volatile gases, the intruder vented large amounts of carbon monoxide, carbon dioxide, and faint traces of hydrogen cyanide, all without a detectable layer of ice. This should have been impossible. Even stranger, its dust behaved with unsettling order, forming ripples and arcs arranged with almost mathematical discipline. Spectral analysis hinted at metallic grains, iron, nickel, and something else, mixed in proportions not seen in any natural object. Was this debris from an exotic stellar environment, or a structure engineered for a purpose we could not comprehend? The glow intensified as it approached the inner system. Its eerie emerald light refused to fade, even though the object showed too little carbon to create such a color. Some theorized unknown chemical reactions. Others whispered about internal mechanisms awakening as it neared the sun. Then came the discovery that fractured the scientific community. Polarization studies revealed that the light reflected from 3I, ATLAS was encoded, bending and shifting as if guided by microscopic mirrors aligned across its surface. And buried within its brightness curve was something even more shocking. A repeating pulse, slow, steady, unnervingly precise. Its timing followed harmonic ratios found in acoustics, not orbital physics. It was as if the object was keeping time. Moments later, the comet's entire structure shifted. The coma flattened, the tail split into perfect spirals, and faint concentric rings drifted outward with impossible symmetry. For a brief span of minutes, it looked engineered, organized, alive. Then everything collapsed. The glow dimmed. The emissions faded. And a single microwave burst erupted into space. It wasn't aimed at the planets. It wasn't aimed at the sun. It was aimed outward, toward the deep, silent dark. The signal wasn't random noise. It carried structure. Its waveform mirrored the object's entire trajectory, a spiral etched into radio space like a mathematical signature. Ground stations, satellites, weather arrays, even ship radar systems recorded the same pulse simultaneously, as if space itself had been struck like a drum. In the days that followed, solar observatories detected strange fluctuations in the solar wind. They aligned perfectly with the microwave burst, forming a vast lattice spreading outward from the sun, an echo of the object's path. The spiral was everywhere, in the solar wind. Beneath that sudden stillness, the background chorus of the cosmos did not fall silent, it rearranged. Buried in thermal noise and routine telemetry, radio dishes around the world began to pull a slow, deliberate frequency out of the static. A low, geometric hum that repeated in lockstep with planetary motions. It was neither random nor purely physical. Each peak and trough lined up with orbital periods, as if the solar system itself had been used as a timing mechanism. Teams at mission control and small university labs raced to stack the data, aligning timestamps from Mars orbiters, lunar seismometers, and Earth-based arrays. The pattern persisted. It threaded together measurements from instruments never conceived to work in unison, magnetometers, plasma detectors, even neutrino monitors, and produced a signal with structure, intent, and unmistakable regularity. When analysts cross-checked archived records, an old anomaly leapt into focus. Voyager's faint flash at the heliopause, once catalogued as instrumental quirk, matched the same signature. Pioneer's idle telemetry echoed the same slow cadence. History, it seemed, had left footprints, we had only failed to look for them in the right light. The consequences were immediate and disorienting. Scientific conferences that had convened for routine presentations transformed into emergency sessions. Funding bodies fast-tracked beam time. Governments privately convened advisors. The public, fed by speculative headlines and breathless feeds, oscillated between awe and panic. Speculation proliferated. Some astronomers proposed a benign model. 3I ATLAS was a probe designed to map environments by seeding resonant fields, a kind of galactic probe that tests the electromagnetic responsiveness of star systems. Under that view, the object's pulses were diagnostic, a gentle tap on a system's natural frequencies to read back its structure. Others argued the signals were a marker, a breadcrumb trail intentionally left for whoever followed, a navigational beacon etched into the medium of space itself. A darker class of theory gained traction too. What if the signal was an activation key? A keystone that, when struck in the right way, unlocked dormant structures embedded in the solar environment, artificial lattices or long-buried machines placed in the remote past by architects whose civilizations predate our own. Lab coats debated the plausibility. Diplomats began to weigh the ethical calculus of interaction. Efforts to respond began with the most cautious instruments available. Phased array radars pulsed low-intensity probe bursts into the lattice at controlled intervals. Deep space transmitters attempted to mimic the 6 long, 1 short pattern. Neutrino beams were modulated and listened for echoes. Each attempt returned nuances, minute phase shifts, thermal transients across the sun's corona, and microscopic perturbations in spacetime detectors. The system reacted, but without hostility. It answered with complexity, not aggression. Layered harmonics that suggested comprehension, not mere physical resonance. As governments coordinated listening networks, international scientific coalitions formed with unprecedented speed. Language barriers and political distrust gave way to shared protocols, standardized data formats, open-source decoding challenges, and a joint ethics board to advise on active responses. The United Nations convened a special committee to examine the broad implications. Secret contingency teams modeled worst-case scenarios for planetary defense and communication breakdowns. On the cultural front, the hum seeped into human consciousness. Choirs began composing pieces patterned after the rhythm. Poets wrote of an alien lullaby. Religious leaders pondered the theological implications of a cosmos that could be addressed. Traders watched markets jitter as uncertainty spread, and artists painted the coded spirals across murals and rooftops. In labs and basements, amateur radio enthusiasts tried to replicate the waveform with improvised gear, while classroom telescopes streamed the changes live to millions. Inside the scientific community, attempts to parse meaning escalated into an interdisciplinary campaign. Linguists applied models of phonology and rhythm to the signal. Mathematicians searched for prime number markers and recursive sequences. Biologists asked whether the sub-frequencies that resembled neural patterns could be an attempt to probe for life. A universal handshake of sorts, testing for the presence of organized, time-correlated activity. If so, the implication was staggering. The probe might be tuned to detect the signatures of life, or even to probe the very concept of sentience using physics rather than language. Yet humility tempered excitement. Many cautioned against anthropomorphism. Harmonics can arise from natural plasmas and magnetohydrodynamic processes. Structured signals can emerge from non-sentient systems under a narrow set of conditions. Rigorous skepticism became the discipline's backbone. Every claim required repeated verification, blind analyses, and independent replication.